Hello, Lovelace. Welcome to today's maths lesson, continuing our work on fractions, which I have to be totally honest, you've really impressed me with. You seem totally confident with everything that I've thrown at you. Well, here's your next challenge. Can I compare and order fractions that are greater than 1? If you remember last time, we were looking at fractions smaller than 1, and we looked at how we would compare them if, first of all, if all the denominators were the same. Then we looked at how to compare them if all the numerators were the same. And we also looked at how we could compare fractions where neither were the same. And we had to use our equivalence skills so that we could turn them into the same numerators or the same denominators. Now, those skills are going to come in useful today. So it's a bit more practice, but our fractions are getting bigger. But let's start with a little warm-up. 4 questions for you. Pause the screen and have a go at those 4. Okay, right, let's take a look. The first one is a straightforward equivalence fraction. So I want to know how many 27ths is equivalent to 2/9. Now remember the rule, whatever you do to the bottom, you do to the top. So to turn our 9 into a 27, we're going to multiply by 3. And we need to do the same to the top. So 2 times 3 is going to give us 6. Okay, so we've multiplied both the bottom and the top by 3. What about this one? Crocodile question. Now, which one is greater? We've got 7/9, we've got 14/18. Okay, again, it's an equivalent question because we need to turn these two into the same denominator or numerator. Now, it's up to you which one you do. You could turn them both into 18ths. So 2 times 9 gives us 18, 2 times 7 gives us 14. Oh, that's curious. So maybe neither of them are greater. They are equal to each other. Okay, so if you'd have turned the numerator into 14ths or the denominator into 18ths, you would have actually got the same fraction. So they're equal. Right, this one, we've got a missing number here on top. Something over 7 is greater than 1. So something over 7 is bigger than 1. Now we need to use our knowledge now of improper fractions. Because if that was 7 over 7, then that will be the same as 1. 7 sevenths is equal to 1. But 8 sevenths, an improper fraction, is bigger than 1. So 8 sevenths would be an answer, but there's lots of others. In fact, if you thought of any whole number, any integer greater than 7, so 8, 9, 10, 11, 12, and so on and so on and so on, you would be correct. Okay, so any number 8 or bigger. And finally, we have got another greater than or less than. We've got 2/19 and 1/8. Which one is bigger? We need to do an equivalence calculation. We need to make these guys either the same denominator or the same numerator. Now, in this case, I would go to try and get for the same numerator. So 2 over 19, and I want 2 over something. Well, I'm going to multiply by 2 to get 2 at the top, multiply by 2 at the bottom to get 16. So 1/8 is equivalent to 2/16. So I'm now comparing 2/9 and 2/16. And if the numerators are the same, then we look at the denominators. The bigger the denominator, the smaller the fraction. Because this fraction has been split into 19 pieces, this one has only been split into 16. So these pieces are going to be bigger. So there's our greater than. 2/9 is less than 2/16. Or 2/16 is bigger than 2/19, whichever way you want to look at it. Okay, so there's your warm-up. So we've got 2 improper fractions here. We've got 2 fractions that are bigger than 1. But which one of those is bigger? Well, actually, this is as straightforward as last week when we were looking at fractions where the denominators are the same. So if you've got your denominators matching, then it's a pretty straightforward question. You just need to look at the top numbers, look at the numerators, and decide which one's bigger. So have a think, but I don't think you'll be thinking too long. Because when the denominators are the same, the greater the numerator, the greater the fraction. So let's just actually prove that. So here we have our 11 sevenths. So there's our whole one. There's 7 sevenths, 8, 9, 10, 11. So there's 11 sevenths. And there's 9 sevenths. Again, 7 sevenths for a whole one. 2 more gives us 9 sevenths. And you can see quite clearly that 11 sevenths is bigger. And so 11 sevenths is greater than 9 sevenths. As straightforward as that. So if we can get our denominators to match, it's a very, very straightforward question. Don't overthink it. What about now? Because this time our denominators don't match. We're going to have to match them. We're going to have to come up with an equivalent calculation so we can match these denominators. Right, well, there's our 7 fifths, 5 fifths and 2 fifths. And there's our 13 tenths, 10 tenths and 3 more. And you can see from the bar model that the 7 fifths is bigger. Now let's see if we can prove that with a calculation, because we can't be drawing bar models all the time. For a start, it takes time, but it's also very difficult to get them accurate. So we know that 7 fifths is bigger, but let's prove that mathematically. So the rule was when the denominators are the same, the greater the numerator, the greater the fraction. But at the moment, our denominators are not the same. So let's make them the same. We're going to make them both 10. 5 times 2, 7 times 2 gives us 14 over 10. So we've now proved it mathematically without having to draw a bar model. 14 tenths is greater than 13 tenths. So there's our solution. Okay. Right, 3 more for you. Pause the video, have a think. What are the answers to these 3? Right, again, we're looking to create the same denominators, which makes the actual calculation very, very easy. So if we look at the first one, we've got 24 as a denominator and 12 for a denominator. A little bit of easy maths. How do we turn a 12 into a 24? Well, we double it. We multiply by 2. So 12 times 2, 16 by 2, gives us 32 over 24, which is clearly bigger than 29 over 24. Here we've got 26 over 21 and 10 over 7. How do we turn a 7 into a 21? Well, we can multiply it by 3. So bottom times 3, top times 3 gives us 30 over 21. And 30 over 21 is bigger than 26 over 21. And finally, we've got 89 over 44 and 6 over 4. How do we turn 44 into 4? Oh, sorry. How do we turn 4 into 44? Sorry, let's go that way. We multiply by 11. So let's multiply both top and bottom by 11, 44 and 66. So we're now comparing 66 over 44 and 89 over 44. Because the denominators are the same, we just need to look at the top numbers. 89 is bigger than 66. So 89 over 44 is greater than 6 over 4. Okay. All of these work because we've come up with an equivalent fraction that's got the same denominator. Right, moving on. So that rule was if the denominators are the same. Can we remember the rule when the numerators are the same? Here we've got 15 over 13 and 15 over 10. Just because they are improper fractions doesn't change how we're going to do this particular bit of maths. So there's our 15 over 13. So 13, I apologize, that's 15 over 10, isn't it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Actually, I've shading by bar model incorrectly there. That is not 15 over 13 at all. So ignore that first one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4. Right. So the bottom one is 15 over 10. The top one, however, isn't. The top one should have stopped there. I got carried away with my pink colouring in. So there's 15 over 13. There's 15 over 10. Either way, though, you can see that 15 over 10 is bigger. So using the Bower model, we've proven that 15 over 10 is the larger one. Well, let's see that mathematically following the rule, because we know that if the numerators are the same, the bigger or the greater the denominator, the smaller the fraction. Because here we've split our item into 13 equal pieces. Here we've only split it into 10, so those pieces are going to be bigger. If we just look at one single square from the bar model, that square is bigger than that square. So if you've split it into tenths, the pieces are bigger than if you'd split it into 13ths. Okay, so sorry about my colouring in, but hopefully you can clearly see that when the numerators are the same, if the denominator is bigger, it's actually a smaller fraction. Let's have a look at this one. So we've got 27 over 24. We've got 9 over 7. How can we use our equivalence knowledge to make these fractions the same as a numerator, the same numerator? Well, how do we turn a 9 into a 27? We multiply by 3. Okay, so let's multiply top and bottom by 3. 9/5 is equivalent, is the same as 27/15. So we've now got the same numerator. And following the rule, if the numerators are the same, the greater the denominator, the smaller the fraction. Well, we've got 24 and we've got 15. 24 is the bigger denominator, which means 27 over 24 is the smaller fraction. So 27 over 24 is less than 27 over 15. Okay. Have a think about this one. Have a go. Okay. Again, we're looking using our equivalence knowledge to create an equal numerator in both questions. So here we've got an 8. How can we make the 4 into an 8 on this one? Well, we can make 4 into 8 by timesing by 2. So times the bottom by 2 gives us 8/10. So we've got 8 over 7 and 8 over 10. 8 over 7. 7 is a smaller denominator, so the bigger fraction. So 8 over 7 is greater than 4 over 5. Right, Rosie and Amir, they both baked some cakes, but they got a bit hungry and ate part of a cake. Okay, so they each baked 3 cakes, but now Rosie has only got 2 3/4 cakes left. Amir has got 2 6/7 of his cakes left. Who has the most cake left? So we're asking which of these two numbers, which of these two mixed numbers is the largest? Right, so there's our question. 2 3/4, is that greater than or less than 2 6/7? Now, the first thing we can do is recognize that both of these numbers have got 2 as a whole. Okay, so as far as working out goes, we can actually just ignore them. They've not gone away. They're still parts of the numbers. They've still got 2 whole cakes, but really we only need to focus on the fraction. So we just need to work out if 3/4 or 6/7 is the larger. So let's take a look. Remember, when the numerators are the same, the greater the denominator, the smaller the fraction. So we can very easily turn 3/4 into 6 somethings. Let's have a go. We're going to multiply by 2, which gives us 3 times 2 is 6, 4 times 2 is 8, which gives us 6 8s. So we've now got 6 8s and 6 7s. Which one is bigger? 6 7s, because that's got the smaller denominator. So 2 3/4 is less than 2 6/7, which means that Amir has got the most cake left. Rosie ate more of her cake than Amir did. Right, your turn. Just 4 questions today. It would be really good if everyone made it to the end of this task. Have a go at all 4, because number 4 is quite straightforward, actually. Don't be scared just because it's one of the later questions. So on question 1, And on question 1, we've got the bar models to help you. Which one is greater? So greater than, less than, or equal to. Compare the fractions. The first one is actually coloured in for you correctly. The second one you need to colour, as well as the third. Each one, which one is greater than or less than. Number 2, there's no there are no bar models to help you this time. You might draw your own, but I'm hoping you can just look for the equivalents. So work out an equivalent fraction and then decide if they are larger, smaller, or equal to. Question 3. Philip's got 3 3/16 bottle of juice. Scott's got 3 1/4 bottle of juice. Who's got the most juice? And finally, for number 4, Rosie's ribbon is 7/4 meters long. Teddy's ribbon is 7/8 meters long. Rosie says our ribbons are the same length. You need to explain why she's wrong. And she is wrong. Okay, so pause the video, have a go at those 4 questions. Right, here are your answers. So number 1, mark along with me as we work our way through. 5/3 is greater than 9/6. And we can see in our bar model, there's 5/3 and there are 9/6. You can clearly see the green is longer, therefore 5/3 is greater. 5/3 and 15/9, if you've shaded those correctly, you will see they're actually the same. And if we do an equivalent calculation, 5 multiplied by 3 is 15, 3 multiplied by 3 is 9, so 5/3 is the same as 15/9. And finally, 4/3 is less than 13/9. And again, if you've shaded your bar model correctly, you will clearly see that the 13/9 is just sticking out a little bit longer. Question 2. For the first one, I will be looking at an equivalent denominator. So we've basically got 14/8, which is greater than 12/8. For B, I'll be multiplying by 3 to give me 21/12, which is less than 22/12. For C, I'll be doubling my 10/6. So I've got 22/12 and 20/12. So 22/12 is greater. D, I'm going to multiply by 2 to give me 10/6, which is equal to 10/6. For E, I'm going to double my numerator this time. So I'm going to have 10/4, which is greater than 10/6. For 5, I'm going to multiply the whole thing by 4 to give me 20/8, which is greater than 18/8. G, I'm going to double my numbers. So I'm going to have 36/16, which is greater than 32/16. On H, I am going to double my 9/4, which gives me 18/8, which is equal. And finally on I am going to double my 18/2, which is 36/4, which is greater than 9/4. Okay, so that's 1 and 2. Question 3. Philip has 3 3/16 bottle of juice. Scott has 3 1/4. Who's got the more juice? The answer's Scott, but if we work it out, the reason is, and we'll just focus on the fraction, 3/16. So we're going to turn quarter into 16, which is multiplied by 4, which gives us 4/16. So Scott has got 3 4/16. So Scott has got more juice. Oops. There we go. And finally, Rosie's ribbon. Well, she says they've got the same amount. She's clearly wrong because, yes, they've got the same number of pieces, but the pieces have only been split into 4 equal lengths for Rosie, whereas Teddy, they've been split into 8 pieces. If you split something into 4, they're going to be bigger pieces than if you've split it into 8. Okay, so clearly Rosie isn't correct. They haven't got the same amount. Rosie has got quite a lot more. In fact, she's got double the amount of Teddy because she's only been split into 4 pieces, whereas he's been split into 8. Okay, that's the end of today's lesson. Well done, guys. Please make sure you're ticking your work. or making corrections where you need to, and uploading it onto Tapestry so I can see what you're up to. Okay, take care of yourselves, look after those around you, and I will see you very soon.